That's really covering the types of testing. We'll look now a little deeper into the pre-compliance testing. This section will look at some of the advantages of pre-compliance and focus also on the physical layer, HCI and Link Layer, and protocol profile testing. So please bear in mind that the pre-compliance test examples given here obviously apply to compliance or validation and qualification testing as well, because that's one of the main reasons for pre-compliance is the confidence during the compliance certification. So you're really trying to reproduce that to give you that confidence. So here are some of the advantages or aims, if you like, of pre-compliance. Firstly, lower test and design costs. So identify problems during development and don't use the compliance to find the issues. Product issues, if left undiscovered until late in the development cycle, can cost significantly more than the cost of the pre-testing itself. And multiple test phases can ultimately result in a functional product, but for every non-compliant verdict, you're going to have to repeat some or all of that process. This, of course, adds delays to product development and therefore increases costs and includes the cost of perhaps lost marketing efforts around a particular launch date that has to be postponed until the product has made its way successfully through those testing phases. Next, faster product lifecycle with the early problem detection. Early testing lets you detect problems before you're sending out your product to accredited labs. By pre-testing the devices, you're able to pinpoint and address those potential problems before the product's been submitted for qualification or validation. And the earlier those product deficiencies are identified in the development process, the easier they are to rectify, obviously. Fixing problems after compliance testing is going to be much more time consuming than fixing them during that design stage. So pre-compliance testing allows you to remedy and fix an issue straight away rather than compiling multiple costly test and redesign cycles. It's obviously far better for a product to remain in the design and development stage until it meets the compliance requirements. Next is the reduced risk of failing certification by testing with validated test equipment. So the pre-compliance testing phase of development is a stage where you subject your product to the testing that it'll undergo in the actual compliance test. This phase can help you determine if a product is ready for submission to an accredited lab or not. But to emerge from these pre-tests with the highest confidence in advance of the final testing, it's crucial to use test equipment that's been validated by the Bluetooth SIG or to get as close to that setup as possible, which give you the highest confidence during the validation and qualification. So Frontline Test Services use Teledyne LaCroix's Frontline family of Bluetooth test tools that are recognized by the Bluetooth SIG as validated systems or as part of validated systems. So I'm going to use those as examples through this webinar because that's what we use for pre-compliance testing for our customers. And finally is the improved end product. So pre-compliance testing can improve performance as well as reliability by detecting the potential problems before they happen on an industrial scale, so going into production. And product performance is improved by eliminating malfunctions before the production begins, as well as improving reliability during use. So the pre-compliance testing ensures optimal product performance is achieved before the product's actually released into production. And that gives you the confidence that your customers are going to have the best possible user experience. So that's covering that, and we'll delve a little deeper now into some of the pre-compliance testing of the different layers. So starting with the physical or RFPHY layer, this is for Bluetooth of two types. The first has a test suite designation of RF. This is the PHY layer for BR and EDR, and it uses the BR-EDR test mode. This test mode supports testing of the Bluetooth transmitter and receiver. It includes transmitter test packets, which are packets with constant bit patterns. So it might be a fixed pattern or a pseudo-random bit sequence, and loopbacks as well. And the tester and the DUT actually form a piconet where the tester acts as the central role, and that's got full control over the test procedure. And the DUT, or your product, if you like, acts as a peripheral. And the control is done via the air interfaces using LNP commands. Similarly, for Bluetooth Low Energy, or LE, that has a test suite designator RFPHY. This is the PHY layer for low energy, and it uses what's called direct test mode. This controls the DUT or device in the test and provides a report back to the tester. So for example, you may want to instruct the product to transmit maximum power to do the transmitter tests, but to do the receiver test, you'll send a known number of packets and you will get from the DUT using the direct test mode, you'll get packet count back. So you can see if you're sending 1,500 packets and the packet count at the DUT is only 1498, you know you've dropped 2 packets there. And the direct test mode is set up using either HCI or through a UART interface, 2-wire in this case. And each DUT has to implement one of those 2 methods, the direct test mode methods, in order to be able to test the low energy PHY layer. So Bluetooth Classic, looking at the PHY testing for basic rate first, or BR, you can see that there are transmitter tests and receiver tests listed here. I've listed the test areas here, but in summary, we're going to be looking at things like transmitter power, modulation, carrier characteristics, and then on the receiver side, sensitivity, resistance in the presence of interference, such as intermodulation or image frequencies, and that's all on the receive side. And then on the EDR extended data rate, again, that has tests on the transmit and receive side. So you can see here, you're going to cover power and sensitivity type tests, but there's also some EDR specific tests, such as differential phase encoding and guard time. So if we look at how we would perform these tests, we use the TLF3000. So that combines, as I said before, generators and analyzers. So we select the test, you can see in the middle at the bottom here, and then we run those tests, and we do this conducted to ensure accuracy. And this slide here is just an example screenshot. You can see it's obviously showing plots and the tests and the verdicts for each of those tests. And you can input obviously the products or DUTs, parameters, the ICs and ICSITs, for example. And then moving on to Bluetooth Low Energy. It's easier rather than just a list to visualize these tests in a couple of tables because they fit nicely together. There's a good cross correlation there. First of these shows again the transmitter and receiver tests you can see in blue sections. And you can see here in the columns you've got 1 meg and 2 meg symbol rates. You've got whether the DUT supports stable modulation. If on the 1 meg side, 1 meg symbols, it's coded. So if it's got supports SS2, SS8. And again, the similar tests of the BREDR, which look at power, modulation, carrier characteristics on the transmit side, and then again sensitivity and resistance to interference on the receiver side. And remaining tests on the LE side are to do with AOA or angle of arrival and AOD, so angle of departure, and these are used in location services. So again, you've got the multiple speeds there and the different switching slot time periods, and then CTE, which is the continuous tone extension, which is sent at the end of the packet to enable this multi-transmitter means of basically direction finding or location. And again, for the LE side, we use the TLF3000, but this time it's utilizing direct test mode to manipulate the DUT. And part of that process is to actually query the DUT. So a lot of the tests are selected automatically. Obviously, you can then vary those parameters and put in the ICSIT values, for example, the N value, any 3, 4, or 5, which affects the intermodulation test. And again, this is just showing an example test run. We've got a plot there of intermodulation performance, and you can see in the top right, there's a failing point as given by the red diamond. So that covers the PHY layer or physical layer. Next up from that, you've got the HCI and Link Layer. And here we're just going to be focusing on low energy. HCI is the interface between the upper and lower layers of the Bluetooth protocol stack. So it's between the host and controller. It's a host controller interface. And the objective of the HCI testing is to ensure functionality and interoperability between a Bluetooth host and a Bluetooth controller. And that allows you to qualify and also allows combinations of controller and host designs. And the HCI being exercised extensively as the test controller, i.e. the upper tester during the link layer and link manager conformance tests. And many of the HCI commands and events are actually implicitly proven within those conformance tests of the link layer and link manager protocol. So looking at pre-compliance testing on the HCI and link layer, so a typical setup shown here on the right. Here we've got the Harmony, which is the HCI link layer tester. That's running the test, and the X240 on the right is used to capture the over-the-air signals. But it's worth mentioning a couple of definitions at this point. So the upper tester is connected to the DUT over HCI UART, and the lower tester is connected over RF, so it's looking at the RF signals. But obviously, again, we connect this conducted. You can see that teed off there from the IoT because we want accuracy on those results. We don't want to get non-compliances because of issues from the environment, for example. And the user can also use the Bluetooth SIG's Launch Studio, so BLS, and that can be used to generate a BLS document, which creates a list of tests that are required. And that BLS document can be imported directly into the Harmony software, and that allows you to automatically select those tests. Or of course, if you want to do some investigation, you can pick and choose a particular test to run. And looking at the HCI first, there's a list of features here that are tested. So starting with generic events, these cover the IoT response to commands not supported or disallowed after receiving your first legacy or extended advertising command. Then device setup or DSU, that's a group of commands that's used to place the controller into a known state. Controller flow control or CFC commands and events, and they're used to control data flow from the host to the controller. Controller information or SIN, and that's allowing the host to discover local information about the device. Device discovery, which again are commands and events that allow a device to discover other devices in the surrounding area. And that's also used to control advertising and scanning functionalities on the link layer. Then host flow control, that's HFC. They allow flow control to be used towards the host. Authentication and encryption, which is what you'd expect it to be, which is authentication of a remote device, and then encryption of the link to one or more remote devices. The controller configuration or CCO, that allows global configuration parameters to be set up. And controller setup, which is used to allow a device to make a connection to another device. Then you have connectionless peripheral broadcast. That allows the use of a CPB logical link to broadcast data to an unlimited number of recipients because it's been broadcast. Low energy oily power control, PCL, that allows the device to query the controller's current and maximum transmit power levels. And then the isochronous streams, so you've got there the use of connected or broadcast connected streams. And then finally the SCO, which is the SCO and eSCO connections. So that covers the creation, acceptance and terminations of the SCO and eSCO connections. Obviously there's lots of HCI tests in the spec, but this is just one example just to show you what you'd expect to see. You can see in the test name, it's an HCI test, so it starts with HCI. Marked in red is DSU, so that means it's a device setup test. And this particular example, which is test 3, checks that the HCI reset message puts the controller into standby and the link layer is then lost. So you can see on the right-hand side, we've got a message sequence chart. On the right side of that chart, you've got the upper tester, which is sending the HCI reset command. And then on the left side, you've got the lower tester, which remember is getting the messages that are going over the air, or in this case, conducted. Moving on to actually testing the HCI, you can see here from this is a Harmony screen. You have the selected tests on the left. So on this one, there's 74, this example, 74 HCI tests. And once you've selected those tests, the IoT or product that you're testing configuration, test results are on the top right, and below that is just an event log. So you can see obviously those tests, and you can get an idea of the duration of some of those tests. So that's HCI, but looking now at link layer features. So similarly, we've got device discovery, power control, broadcast, connected isochronous streams in there as well. This time device discovery, that's looking at advertising and scanning modes between multiple devices. We're also verifying correct addressing of devices, the correct content and correct checksums in the packets. And then connection handling, that tests the connection setup, flow control, the acknowledgement schemes and terminating connections. Timing, which is test procedures during the connections, varying the timing within the allowed clock drift against the UT, observing connection parameters for those different roles as well. Radio frame encoding, which is ENC in that list, that tests rejection of the packets if there's an invalid preamble or access address. So in other words, you've got incorrect content in the link layer packet sections other than the PDU and the CRC. And frequency hopping, which is looking at the channel selection algorithm. Packet formats, which here we're looking for rejection of packets with invalid logical structure for dependencies or content. Security, so that's testing the encryption mode during operation. Also, it's testing encrypted address usage during device discovery and encryption of the packets in the connected operation as well. Then as before, we've got the connected and broadcast isochronous streams. Isochronous test mode, so this tests the isochronous test mode, so that allows you to test the connected or broadcast stream transmission and reception with that isochronous data. And then finally power control, which again tests the control of the transmit power of a remote device and requested path loss monitoring, that sort of thing. So for link layer as well as the features though, we've also got functions. So you have your advertiser, scanner, initiator, for example, and central and peripheral roles. And just picking a simple example from the specification, you can see here we've got the designation LL for the test, then DDI for the feature, so that's in red, ADV in green, that's the role, so in this case, advertising. Then you've got the simple example test where the IoT is stopping advertising after it's received a connection request. So obviously a product's going to be advertising, it receives that connection request and then should stop the advertising. And on the right there, you've got the message sequence chart. Again, you can see the HCI commands coming from the upper tester. So if you remember before, I was saying, even though you're testing link layer, you're implicitly testing some of the HCI as well. And then on the left, you've got the RF communication with the lower tester. So you can see obviously the advertising and then the connection coming in. And again, this is tested with Harmony. I won't labor the point, but another screenshot here showing the link layer tests. You can see here 667 of those. And again, you're running through those tests. So the ones on show here are taking sort of 20 to 30 seconds, but some of the tests can take quite a bit of time. So one of the advantages of pre-compliance that many people overlook as well is you can also not just repeat the compliance tests to get confidence in that, but you can also use custom test cases. So that gets you a deeper understanding of behavior, or can be used to find out some more info if you want to fault find. And this list is just an example of some of those tests that can be modified to transmit and receive packets from the LT or the IoT, verify repeated BIS connections, terminations, etc. So having covered the PHY and then the HCI and the link layer, just a quick brief look at the profile testing. And this time this is used using Bluetooth SIG's PTS or Profile Tuning Suite, and that's available to registered SIG members on the website and currently at version 8.1, I think. That's used in conjunction with one of the radio modules. There's a dual mode dongle, which has been out for some time, that covers up to 4.2. It also supports mesh if you have two of the dongles. As I said, you can go to the SIG website, bluetooth.com, and go to the qualification section, and there's links there, and that allows you to get this dongle. And that dongle, when you receive it, is pre-installed with the PTS firmware, so there's nothing to do with that except plug it in and run the software. But then there's also the LERD dongle, which is required for the extended advertising. I've got here up to 5.2, but obviously in July 5.3 was released. This time it requires firmware to be downloaded from the SIG site and then uploaded onto the dongle itself. So you've got to be careful. There's a extra process to put that specialized firmware on there. And then it's also a protocol viewer, which used to be combined, is a separate tool now from PTS to allow you to view the decodes of over the air. This is just an example screenshot from the PTS. So here we're just running some AVRCP tests, and you can see the log in the top center. You've got the ICS exit window and the test cases in the bottom right. And again, they're tested with the dongle. So I've just got a picture of the two dongles there, the PTS one and the LERD connectivity one.